So we will continue. So last time we almost finished this one. Encoder, this part. So I said, I keep talking the same thing. So VGG is important. GoogleNet is important. ResNet is important. So that's all three are fundamental encoder. Even though right now people still use the good paper, they still use this one, but they modify because this is not so complicated. So it's easy to modify. Okay. But he's getting complicated. This is also complicated. So this is some on page 33. Page 33. Okay. So we talk about AXNet, but remember AXNet is 5 plus 3, but this has only 3 downsampling. Here only 3 downsampling. 1, 2, 3 downsampling. So don't use AXNet. Don't use it because we already know VGG16 is better than this one. Okay, but it's also simple. So don't use AXNet. Okay. That's my suggestion. But VGG16 has a 5 downsampling. Okay. So each card is 1 downsampling. So divided by maximum pooling, right? So for downsampling, if I ask you how many, if I ask you to select for the midterm, if I ask you following 4 methods, okay, which one of which 2 methods for downsampling? So downsampling one is the maximum pooling, right? Maximum pooling for 2 by 2 maximum pooling, or straight 2. Straight 2 is also one kind of downsampling. So for the question for my midterm is like that one. I will tell you. I will tell you like if they have 4 and if you I say based on the four answer, but pick up 2. Which two are the answer for downsampling? 我不会那么邪恶，叫你说4个，然后自己去猜看几个，不会，我会跟你讲答案大概几个。好 ，so this one and this 3, okay, this 4 connected, flattened and 4 connected. This 4 classification. So this VGG16 or VGG19. Okay, VGG19 is 16 by 3. And GoogleNet is more wider, right? And GoogleNet, they have a 1 by 1 convolution, 3 by 3 convolution, 5 by 5 convolution. So they have a different kind of decision field to extract local information, extract a little bit global information, wider information. So that's more fact. So that's GoogleNet. And ResNet have an identity. They have a shortcut. So that's the ResNet. Some people try to change this one inside here. So ResNet, some people combine this one. See, this is shortcut. This is shortcut. Don't see this too much difference. No. There's shortcut here. There's shortcut here. Okay. Or even they don't use this one, just shortcut here. But inside here, what I said GoogleNet, people start to change it. Sorry, VGG16, people change this one. GoogleNet, they try to modify a little bit. Like this one, people also modify ResNet. For example, this one, right? This path is the same as this path. The people change it. Okay, they do global pooling. They do fully connect. What is FC? FC. Anyway, they should do the convolution, fully convolution. It should not fully convolution, it's convolution. They do convolution, they do sigmoid. But last time I told you, right now people change it to convolution, batch normalization, renew. It's already old, so people right now do convolution. They don't use global pooling, no, don't use here. They do convolution, batch normalization, and renew, or sometimes renew change it to the decay renew, something like that. Okay. But in the final one, they do sigmoid. Remember, sigmoid in the final output, they do sigmoid, not here. Because sigmoid is try to be output between 0 and 1. Okay. So this is I organize this one for you. And this is some application for VGG16. So this joint, right? They can do joint. So this we did. My lab did that. So we use VGG16. Okay. Like that. 这种 VGG16 做的。那 CMU 这个做的更好，做这个。所以不一定要用很复杂的，这你自己在当的这个 open source 的东西，他做的非常好。
On this night of NBA stars.
Okay, we go to the next one, is a multitask. Multitask. So this one only encoder. Multitask, we want to do detection and also classification. So we need to do the upsampling. So here we talk about first RCA and mask RCA is basic. And then YOLO, YOLO. 这边抱歉，这边我没有搞清楚，应该是这个，一样忘记把它拉过来。那这才是新的。The famous one for multitask include detection and classification of first RCA and then mask RCA. Here is a retina. I always tell you retina is very important. There are many technology in retina, include the loss function. Retina here is important. And forget the YOLO V1 and V2 is already old. And YOLO V3, actually YOLO V3 considers some technology from retina. And YOLO V4, they combine not only the YOLO V3, they also combine retina and the DNet. So the YOLO V4. I told you again, YOLO V4 already a little bit complicated. It's not easy to modify. Not easy to modify. So if you want to use it, it's good. You can use it, right? But it's not easy to modify. This is very good one. 我们实验室也没有，我们有拿来用，当然有用，还不错。但是因为不好改，所以没有完全用这个。So this section we talk about is we not only we want to detect and classify to be car, people. So what's a multitask? Two kind of multitask. One is usually we input is RGB, right? It's RGB input. Right now we have a RGB and a D input. That's this page. here, page 58, we have RGB and D, because right now we have D information, more depth information, so RGB and D. So that's a multi-input, multiple input, and multiple output. Okay, so this is for example. So suppose we use a VGG16, so we have 5 blocks and 3 layers, right? This is for classification. So this classification, because my level we use a robot arm to pick up the stuff. So we want to estimate rotation angle for the object. So this is the rotation angle, and this is the object. So suppose we have 5 objects, 1, 2, 3, 4. Sorry, 4 objects. 1, 2, 3, 4. 4 objects. So you hope your output is not only identify the objects, but also try to identify their rotation angle. So we have 2 sets of outputs. So what can we do? So the advantage for the network, 这个是那个 network 的好处哦。For the machine learning, they cannot do that. Machine learning, if we do this one will be separate. Machine learning is separate. For deep learning, they can combine together. Okay, so first of all, suppose I want to identify the rotation angle of the object, and I can this object. So suppose they have a 360 degree, but for the robot arm is 180 degree because it's symmetric. So 180 degree I divided by, suppose I forget, I think the, as I remember, the 18 angles here. That's 8个角度了啊，每10度一个18个角度。Okay, so I can identify the angle. Okay, so the output will be 18 outputs, 80 angles. So this can be one VGG16. The other VGG16 is simple, you just try to do the classification. So both VGG16, they were the same input. So the same input for one VGG16 output is angle. The other, the same input, but the output will be the classification result. So that's meaning we can combine both together. So when you design this kind of multitask, first of all, you should separate. I teach you, should separate for different output purpose, and then you do the combination. Okay, so you'll find, so we combine, and then this is a classification using the NLP 3 layers, NLP 3 layers. So we have output 3 layers, we output this one, so that's fine. So for the extraction information, what we did is first of all, already you come here and then come here, right? You can shortcut here, but it's weird. Why? Because this is for angle, this is for the classification, the object classification. So suppose the extraction information should be different. So you cannot have a directly shortcut here, and we don't need this one. This is incorrect. So we still need some extraction information. So that's why we have one more layer here. So we shortcut here, and here we do the extraction and got a result, and the result is good. Okay, so why not 2 layers here, 2 stage here, 1 stage, 2 stage here. So we do 2 stage here actually. But we find out because this one is only 4 classes, it's simple. So even though we have a 2 stage here, the result is not better, it's the same. So we find out we don't need 1 more stage here, which is directly from here to here. So this is only 1 input, we have a 2 set of outputs. 所以像这种你要输出到底要几个 layer， 就是这里要用几个 stage， 这个真的要靠经验。只是你要可以分析一下，因为这只有4个输出嘛，4个 class， 所以这个不难，所以我们只要一个 stage 就好了。如果这里更复杂，你可能要需要2个 stage， 就2层了，变成这里的参数跟这个参数。所以这里为什么只有1层？因为这只有4个种类的输出。当你输出种类越多，这里可能要越多层。这样子。而如果这里又变成5层的话，那就失去 combine 的意义了嘛，对不对？你这里又变5层，那这2个就不用 combine 了。通常不会发生这种状况。通常我们是 combine， 意思是希望这里已经5个 stage 了嘛，我们这里就不需要那么多 stage， 这样，因为前面可以共用。好，那就是一个 multi-task 的基本。那我们那时候是这样做，有成功，这个就5、6年前了。看一下我们做的结果，一个李超学长他们做的，这样做的，这让他学习，让他去自己学习，就在那边让他自己学习。那这里有 this is sensor here, so they will know which angle, which position they can successfully pick it up。一开始学笨笨的嘛，让他这样去做，就放在那边，让他自己去学习，自己去摸这个东西，这样子自我学习。让 VGG16 做，这是我们直接用 VGG16 做而已，就让他再摸，这也是让他自己学啊，就是 which angle is better。We don't teach him, just let him to learn by itself。你看他抓失败，就他知道这个不行 ，this angle is incorrect if they fail， 就让他一直摸，好摸到最后他就熟悉了。忘记好像训练12小时吧，让他抓了12小时抓完以后，他就越来越聪明。干嘛一个，让他这些东西自己去抓。这是 this one kind of self learning。他已经现在有功力哦，具备有抓这些东西的能力了，就很准了。所以有时候跟机器人相处，把它当成自己的小孩，这是你写的程式，那你会不会跟这个机器人有感情？这个机器人看起来是不会有感情的，可是我这个是弄成一个很漂亮的形状，你跟它会有感情，有可能，因为它越来越聪明，越来越听你的话。重点是它会听你的话，全世界都没有人会听你的话，只有你的机器人会听你的话，所以你会跟它产生感情。这是日本人最会的，因为你跟他讲什么，他就学什么。所以有另外日本有一群人在做这种，让他就外表装饰的毛茸茸的，很好摸啊什么的，皮肤很好摸的东西，这样就会跟这个产生感情。但我意思是说，我们证明，你只要简短的 VGG16，它就会乖乖的听你的话，这样子。所以以后你可以在家里叫他去帮你拿个冰箱，拿个什么东西，倒个什么东西，他就乖乖的帮你做。好，这时候我们就越来越聪明。这个我们有成功的，这个刚那个是有成功。那这个就另外我们跟工业界做的例子让你看一下，这个都用 VGG16 做的。因为 we use VGG16 就可以做这些东西。这个是耍宝的，学生说啊，让他耍宝一下，就这个转一圈啊，学一下，他觉得太无聊了，让他接手被耍宝一下这样子，那这很无聊啊。机器人就做这种无聊的动作，这是动的东西，这5、6年前做的。相机在这里，像 camera is here。camera this is that time they use Kinect. Right now we don't use Kinect. Right now we use the real sense. Kinect 停产了嘛，我用 real sense。 这个做这个有点无聊，这是物理，可是那个产学合作公司需要这个。纵使这个硬邦邦的，做久了，学生还是跟这个有感情。他说：“学弟，你不能碰我的东西，这是我硕士的东西，碰了以后他要修理哦，所以那时候不准人家我们下面画一条线，不能进去这个禁区，学弟都不能进去。学长快毕业了，他把你把这个当成宝。好，再继续。Okay, so multitask is input, right? Okay. So we combine this RPN, rigid proportional network, so they will do bounding box detection. Based on the bounding box detection, the output here. And let's do segmentation. So there's a mask here. And then output here. And this for classification. You classify this is the person, this is the host. So we have so the output has a bounding box, has a segmentation, has a classification. So there's a multitask. But remember, this one is different from this one. This is parallel output. This is parallel output. This is one output become next one, next input. Combine original feature and output information. And there's output here and combine together. So previous one is the parallel output. And this one is the output is based on the previous the input is based on previous output. So it depends on how you apply how you build your network. Okay. 所以哪一个比较好，真的就是有不同的做法这样子。那我这里再重新，我这里帮你整理。我比较都会我一阵子就会替学生整理一些东西，这样比较好。Okay. The purpose is first RCA. This mask RCA. Let's find out. And what's the difference from RCNN to SPP native for first, and there's faster, and there's mask. So before the same, 这个 he 和鸟没有合吧？哈，大陆人合，他做这方面，他是微软的，现在好像跑去 Google， 从微软跑去 Google 的样子，做得非常好，这是一个非常好厉害的人。So original region CNN. So they do the bounding box use the computer vision because the purpose is they try to do segmentation. 他就要做那个 segmentation. 那做 segmentation 之前 year 2014 they don't have a detection. So they use a traditional method called selective search. This traditional computer vision method for bounding box detection. But for the segmentation, to foreground background segmentation, they use deep learning. And then next year, the same group, 这是另外一个，这两个是 the same group. They developed the first RCNN. They still use computer vision for bounding box detection, for object detection. Okay. But they modify XNet or modify BGG become what? Become fully convolution. It's fully convolutional network. Before they use fully connection. But the first RCN is the first paper using fully convolutional network. 就是我之前讲的这个。这第一篇 paper， 我所了解的是第一篇 paper， 就这个，这里，这是 fully connective， 就 flatter 嘛，然后连在一起。 So the weakness of a fully connection is that the input size cannot change because this is a fixed. So this is not good. So they change it to be fully convolution. It's 3x3 filter. So the input image size can be any input image size because they use fully convolutional. Okay. And fully connective is this one, input size cannot be changed. So that's this one. We call this first RCNN. They use fully convolutional. Okay, they change this one. But still, here is a computer vision. They use a computer vision method called selective search. So it's not complicated deep learning. So for this kind of region CNN, the first paper purely deep learning is the first RCNN. So first RCNN they apply RPN, FCN fully common. So they change here. Both difference is a convolutional and convolutional and connection。这两个不一样是这 F 这里，这两个不一样是 this is computer vision method and this is a deep learning method. So they develop RPN. RPN 是什么？就我之前讲的 two stage， 这是 RPN 这个。一开始这个方法，这个 detection 是用传统的方法做 detection， 就电脑视觉，然后后面做 classification。那我们回到就刚刚讲的，那这是 first RCNN， 它开始用 RPN 来做，他们发明的 anchor。那 RPN is just for bounding box detection. Foreground, background, they don't do classification. So classification here is just background, foreground, region proposal. 所以是这里帮你整理，这 first RPN 这里发明的。So bounding box. Now mask also use RPN, but difference is pixel-wise segmentation. Foreground, background. This is bounding box, and this is pixel-wise mask. 我们称为 mask， 因为它有个 mask 把它罩起来，就这里有个 mask， 这里有个 mask。Foreground, background 这里有个 mask， 二分法的。那我们继续。So first RCN is this one. Input image, you first RCN, and first they can detect this one. Region proposal only detect like grade 1. Region proposal is just roughly bounding box detection. But later on, the same data detection is to use regression to the better result of the bounding box. Region proposal here, region proposal 是大略这样框起来，因为它用 anchor 框起来。那后面有个 regression 的，一样这个后面 regression 的 loss function， 它会把这个弄得更准这样子。Mask is segmentation, pixel-wise segmentation, foreground, background 这样。And then identify, classify who is who. 那所以我们回到所以 first RCN and mask RCN actually almost the same. We do image, we do convolution, but we use RPN. In first RCN, mask RCN, they already have modularization. 他们已经模组化了哦，他们已经有模组化的观念了，所以这个是 encoder 嘛 ，feature extraction。那这是属于有点属于那个用 RPN 来做，把 bounding box 找出来，然后 normalize， 然后 this is head， so this part head So here have a continue to do the feature extraction and for the classification. So this one is classified different classes, people, cars, something like that. So they have a softmax. Softmax is normalized. Not all the output normalized to be 1, so softmax. And this one is bounding box regression. Regression is I want to do the better result of bounding box. This is the roughly bounding box. This is more precise bounding box. We could use a regression. And this part is a mask. Mask is a segment. Continue to do the convolution to extract the information. But both parts is important. Is both parts is upsample. Until here is only encoder. Up to here we have upsample. Back to the original resolution, and we do the mask and try to segment the foreground picture. And this is the same. This one is the same as this one. So this is here is head for bounding box. Here is for segmentation. Okay. And we already tell you about it here, right? The 1 stage and the 2 stage. But both use anchor. But before YOLO V4, this one, the result, because it's 1 stage, so the result is not as good as the 2 stage. But YOLO V4 have a good result here. Okay. 2 stage is slow. Okay, it's slow, but actually not so slow, it's still fast. Okay. But they have usually they have a better result for the bounding box. Okay, so next one, what I try to let you know is the anchor. ANCHOR, this one. What's the anchor? This anchor. So no matter is 1 stage. Go back to page 48. No matter is 1 stage or 2 stage RPN. There's anchor here. What's anchor? First of all, I would like to let you know is suppose they've already done sampling. So suppose this is 7 by 7, right? We use the VGG. Here. The VGG here is 7 by 7 pixels here. Downsample 7 by 7 pixels. And we do upsample. So 7 by 7 pixels. Back to here. Page 49. So this is 7 by 7 pixels. Here we call grid, G-R-I-D, 格子，7x7的格子这样子。对啊，好，那我们到这里了。这里的话呢，在讲什么？他在讲说 ，for each grid, or next page, suppose it's 7 by 7 pixel here, grid here. For each grid, we have 9 anchors. 9个 anchor. What's the anchor? It's meaning we have a 3 ratio. What's the ratio here? 就这个就是啊，你看这个假设 grid 是这样，32平方60，一直 upsampling 上来。But for each one, suppose we have this is this one scaling 大小，那有3种不同大小，一个是2的0次方，2的3/2，2的3/2。分成3种不同的 scaling， 所以只有3种，1种、2种，然后3种。For each scale, we have a ratio, aspect ratio is a 1 by 1, 2 by 1, 1 to 2. This is for like a person, people stand up. This is for like a car. And this is for some like a, I don't know, animal or something. This ratio is 1 by 1. So that's meaning for each grid, we have a 9 anchor box, different scaling, different ratio. And based on the 9 anchors, we try to know whether there's an object foreground or without object. 我每9个，就每个 grid， 刚讲是7乘7个 grid 嘛，你到这里的时候是7乘7哦。那7乘7，你每个 grid 你都有9个 anchors， 就9个 bounding box。那 for each bounding box, you try to identify whether there's an object or without object. 所以它是2分法，所以 RPN 是2分法 ，object 跟非 object。我们举例来讲，这里假设狗在这里，那你每个 anchor， 我说每个 grid 有9个anchor， 然后你发现这个的话是2比1，在这2比1这里就找到一个 bounding box 在这里，因为每个 grid 它有9个 anchors， 那9个 anchors， 它去找这9个 anchors 里面有没有存在物体，而且这物体的 ratio 是符合1比2、2比1、1比1，你会发现这只狗它符合2比1的这个脚踏车在这中心点 ，grid 的中心点，它符合1比1，后面这辆车子中心点在这里嘛 ，the center is here。So each grid there have 9 anchors, and if you find this anchor is a ratio 2 to 1, and center here, so we have a bounding box match as a result. This is loss function. RPN 本身有 loss function，loss function 会帮你判断这些东西。loss function because 因为 ground truth， 你当然跟 ground truth 比，那 loss function entropy 我忘记这里哪边有没有写这个 close entropy 的东西，都没写 loss function。它会跟 ground truth 比，那 ground truth 已经有 ground truth， 它会看这里是不是有物体这样子。所以以这个例子来讲的话 ，each grid have 9 anchors, but finally based on the ground truth, based on your loss function, you only find there were 3 bounding box exist objects， 就3个有 object 这样子。那这个是 roughly 啊，因为不是很准，框的不是很准，它是大概，这都框的不准，所以 RPN 这 region proposal just roughly do the bounding box for the foreground object and background. They don't have a classification. RPN has no classification. They just detect whether they have a foreground object or background object. 它没有 classification， 这是 RPN 的目的，就很快的帮你找到一些 candidate 这样子。好，这样懂吗？这很重要 ，RPN 重要 ，RPN 非常重要，就帮你处理。像这个都没有找得很漂亮，但是它至少有知道物体在那边。会不会误判 ？RPN 我们刚刚讲的，我宁愿让精确度提高，错误率提高，我也不要 miss 掉这样子啊。So RPN their loss function basically they have a try to have a higher recall, higher precision, but also their false positive, false negative are higher。那没关系，后面我们再做过滤的动作。所以这 RPN 的目的在这里。Region proposal. Okay, so there 我没有写 loss function， 那样写。So their loss function is 2 loss function. One is 2k. What's k? K is anchor. So anchor box. So if here k equal to 9. So we have a 2 is what? 2 is a class. Foreground and background. So we have 2 class. One is the foreground, the other background. So we have 2. So for each bounding box, we have a for the classification, we have a foreground and background, but we have 9 anchors. For the bounding box, they have 4 parameters. One is X, Y, W, H. W is the bounding box width, bounding box height. What's the X, Y? X, Y position. Sometimes position in the left top left corner, sometimes position is at the center. Depends. 有时候 X Y 的位置是中心点，有时候是在左上角，一样这没什么，因为你知道它的长跟宽嘛。所以它有这个4个是 bounding box 的参数，这2个是前景跟背景的参数。这样子。So that's for RPN 啊，这是 loss function， 上面是 loss function， 因为 loss function 就是你把这个跟 ground truth 比这样。那 ground truth 也有 bounding box， 只是这里做的 bounding box 不是那么准。可以哈，因为 RPN 很重要，因为 one stage the concept for one stage they also use anchor， 一样的，也都用 anchor 来做，先粗略估位置出来，然后再做 regression， 这样子。好，那老师一直讲 retina 很重要 ，retina 很重要。那 retina 因为里面很多技术 ，inside retina there are many technology。But here actually retina。The other is they also use bounding box. So this is retina downsampling, upsampling called feature pyramid network. We are upsampling, downsampling. Sorry, downsampling, upsampling. Actually, the other important network we call UNet. UNet is very important. So we have VGG. Okay, we have a Google Net. We have ResNet. The other important network we call UNet. UNet is exactly the same as this one. 不要忽略 UNet 很重要，也很好用啊。那这是为什么称为 UNet？ 上次讲过嘛？没有，它是标新立异而已啦。就是你看这个是 V 嘛 ，U 它是倒 U 嘛，啊 UNet 就把它倒过来，这样叫 UNet。你把这个图倒过来，倒过来，这就 UNet。这一样的，只是变成这样子。它就是反正就是我跟你不一样，就这样子。文人相亲嘛，没什么。好，只是让你搞混哦，实际上都一样。For each output stage here, there were 2. So this one is for classification. This one for bounding box. So retina net here actually is the same as this one. Retina 这个 retina 这个输出这里，实际上跟 RPN 的这里一模一样，一个是 XYWH 嘛，一个是 K 嘛，然后用 anchor 来做。但是这个是 one stage， 它是用 anchor， 它没有，它是改良这个嘛，这是额外一个 RPN， 这额外一个 RPN。那 retina 是直接这样输出，只是它有 anchor， 然后 loss function。那这里要小心一下是，往哪边有写？这里的，记得哈，这有 convolution， 这里还是有 convolution， 不是没有的哦。This is a convolution. This is downsampling. This is upsampling. So upsampling here is convolution. So that's here. We have a downsampling 这个 convolution here. Upsampling also has convolution. 不是没有的哦。Upsampling has convolution. 所以你不要以为看起来好像没有，这里都有 convolution。这个就是 upsampling 的 convolution. So this is sorry. This part, the same as this part, the convolution. And this head. Head is try to use anchor to do the object detection bounding box. But retina good is not only here. Retina, they are good is they have the loss function. They modify a lot of loss function. And this for each stage. each stage has this one output. And final output will do fusion. We call non-maximal separation. I will talk about that later. Non-maximal separation will fuse the output to be only one bounding box, or just they will overlap and just reduce the redundant bounding box. Okay, so today we up to here, almost done. Unity here. Okay, so I'm almost done for this one. And next week we'll talk about SAMIS 双胞胎的 network. Now we will talk about this one. LSTM for the temporal domain. 开始，我们今天都快讲完了，那我们就开始讲 PCA 这样子。Okay, so that's it for today lecture. Thank you. 谢谢你们，有问题再问我。